Hello, my name is Amy Petersen-Wines. It's an honor to be here today. I'm here to discuss some interesting findings from a study conducted by myself and Dr. Will Russell. We looked at structural and compositional features following selective harvest in Santa Cruz County. So I would like to start off by thanking our funders for this project, the Kiwanis Club of West San Jose, as well as the College of Social Sciences at San Jose State University. And on to our introduction. I'm sure there are a number of forestry professionals and land managers in this room, and you're probably all well aware of what selective harvest entails, but I thought I would do a quick review just in case. So selective harvest is an uneven age management system in which small groups of trees are periodically selected to be removed from a larger area so that age and size classes of the reproduction are mixed. State requirements allow up to 60% of trees in a given area to be removed, and those trees must be at least 18 inches in diameter. There's been minimal research on selective harvest, especially in the southern range of coast redwood. And since this is currently the primary method of timber extraction in Santa Cruz County, it's important to understand the potential impacts of this method of logging. So selective harvest or single tree selection is considered to be the least ecologically damaging timber harvest method. When trees are selectively harvested, the end result is lower harvest yields. And lower harvest yields, while still providing economic gain, allow for the forest to regenerate at a faster rate while still maintaining structural and compositional integrity. When I talk about structural and compositional integrity, I'm referring to features such as snags, fire hollows, and complex canopy cover, the canopy structures that support a number of avian species, including the sharp-shinned hawk and the golden eagle. I'm talking about large woody debris, which act as habitat as well as a stream buffer. I'm also talking about retainage of understory floristic species associated with this forest type. These associated plants may take decades to recover following an intensive harvest, and therefore a lighter cut is also more beneficial in maintaining species diversity. These habitat features promote conditions for a number of species that favor old forest conditions, including the varied thrush, the hairy woodpecker, the California giant salamander, and the California newt. So when we started this research, our objective was to determine how forest structure and composition varied in regard to harvest intensity and management goals. We sampled 100 plots at the Byrne-Milliron forest at 5 harvest sites. All sites had been essentially clear-cut at the end of the late 18th and early 19th, the end of the early 19th and late 19th and early 20th century, getting stuck there, and subsequently selectively harvested in the late 20th and early 21st centuries. 4 of the 5 sites have been managed primarily for timber production, while the 5th site, the late successional unit, has been managed for old forest conditions as well as timber production. We looked at 3 explanatory variables: years since last harvest entry, percentage cut per hectare, and number of harvest reentries. We predicted the late successional unit would contain more late sterile features, hence the name, and that the presence of those features would be positively correlated to years since last harvest and negatively correlated to number of harvest reentries as well as percentage cut. On to our study system. Purchased by the Land Trust of Santa Cruz County in 1984, the Byrne-Milliron forest is 322 acres, 200 of which are coast redwood. Of that, 80 acres are permanently off limits due to steep slopes and proximity to streams. In 2007, the Land Trust acquired the adjacent mill iron property through a conservation easement, and then the subsequent year, the following year, they purchased the property outright. But for the purpose of this study, the mill iron property has been excluded. The method of harvest at Byrne is referred to as conservation forestry by the Land Trust of Santa Cruz County. Forest management is designed to reduce tree density and provide age diversity, and trees are hand-selected. Site selection was determined through applicable timber harvest plans as well as non-industrial timber management plans, as well as ground surveying. And we had 5 sites that we looked at. The 1987-2004 harvest site, the 1990-2007 harvest site, the 1996 harvest, the 2001 harvest, and the 2007 harvest, which I'll be referring to as the late successional unit. Here's an illustration of the land management map, and there have been a total of 7 selective harvests since the land trust took ownership. The property is now broken up into several sections, as you can see, including the central unit, which is that middle band that encompasses the 1987-2004 harvest, 1990-2007 harvest, and the 2001 harvest. And the lower blue, we have the successional unit, where the 1996 harvest is. The early successional unit was not part of this study, and then in the upper right-hand corner, we have the late successional unit, which was the 2007 harvest. Now, I'm going to go through this information in a little more depth momentarily, but I wanted you to see the numbers side by side. Each harvest area is listed in hectares, and the sites that were entered twice have 2 figures, one for each harvest. The values for percentage cut reflect the most recent harvest entries. Looking at things more in depth, we have the 1987-2004 harvest site. At the time of this research, it had been 9 years since the last harvest, 2 harvest reentries, 22.78% cut per hectare, initially harvested under a THP in '87 and then followed up with an NTMP in 2004. And we have the 1990-2007 harvest site, 6 years since the last harvest, 2 reentries, 32.49% cut per hectare, which is actually the highest cut of all the sites evaluated. Harvested under a THP in 1990, followed up with an NTMP in 2007. The 1996 harvest site, 17 years since the last harvest at the time of this research, 1 reentry, 25.45% cut per hectare, and harvested under a THP. There's actually a subsequent harvest that occurred last summer, but we haven't had a chance to take a look at that yet. The 2001 site, 12 years since the last harvest, 1 reentry, 29.47% cut per hectare, and harvested under an NTMP. And then last but not least, we have the 2007 harvest site, the late successional unit. 6 years since the last harvest, 1 reentry since the clear cut at the turn of the century, only 17.48% cut per hectare, and harvested under an NTMP. Unlike other management units at Byrne-Milliron Forest, this area has different goals, which include minimal logging and an overall reduction in disturbance in an effort to promote late successional features and maintain habitat features such as snags and down woody debris. Moving on to our data collection. So we had 20 sample plots, each 20 meters in diameter, which were randomly selected at each of the 5 sites, so totaling 100 plots. All plots were situated at least 10 meters from sensitive habitat, 200 meters from main access roads, and each plot was further divided into 4 sample wedges to determine herbaceous cover. We looked at the following variables: identification and diameter measurement of all tree species larger than 10 centimeters, ocular estimation of herbaceous cover, measurement of large woody debris, estimation of canopy cover, as well as geographic characteristics including elevation, aspect, and slope. For data analysis, we looked at the following dependent variables: stand density, coast redwood density and size classes, coast redwood dominance and basal area, canopy cover, large woody debris, coast redwood associated species, as well as species richness. Analyses were, data were analyzed using one-way ANOVA, with post hoc analyses conducted with the Bonferroni correction. Correlations were determined using the Petersen product moment correlation coefficient. It's a mouthful. Okay, and taking a look at the coast redwood associated species, we looked at Pacific starflower, Pacific trillium, Hooker's fairy bells, redwood sorrel, modesty, and redwood violet. Now on to the exciting part, the results. So forest structure and composition varied significantly between sites, with differences found in canopy cover, stand density, density of large woody debris, coast redwood associated herbaceous species, and several other metrics. First, we'll take a look at stand density. Tree species identified at Byrne-Milliron forest included, of course, coast redwood, tan oak, Pacific madrone, Douglas fir, and a mix of coast live and interior oak. As you can see, the late successional unit had the lowest stand density among all sites. Our analysis determined a positive relationship between stand density in relation to number of re-entries as well as percentage cut. Variation between sites in regard to individual tree species was particularly pronounced for redwood and tan oak. These species had a much lower density in the late successional unit compared to all other sites evaluated. Variation between sites for the other tree species was all within the margin of error. Results also indicated that density of redwood was significantly higher in stands entered twice versus stands entered once. Similar to cumulative density, stand density of redwood was shown to increase in relation to both number of reentries and percentage cut. Moving on to coast redwood stand density across size classes, notice this great size class distribution that we have for the late successional unit. This is the size class distribution that we would expect to see in a healthy forest. If you examine the other sites, there's an abundance of smaller stems, and a mix of age and size classes is of course most ideal. When analyzing the different size classes, we determined that stems in the smaller classes increased in relation to number of reentries, whereas the larger stems declined. Here is a snapshot of what large woody debris looked like at the preserve. The structural feature was found to decrease in relation to percentage cut. Notice that the late successional unit had the highest density of large woody debris. And now looking at coast redwood-associated herbaceous species, we determined that their means declined significantly in relation to percentage cut. And this relationship exhibited the strongest correlation among all analyses conducted. Again, note the late successional unit had a higher mean in comparison to all other sites. Moving on to canopy cover, 4 of the 5 sites examined were within the margin of error. Canopy cover was determined to decrease in relation to years since harvest and percentage cut. Again, note that the late successional unit had the highest mean canopy cover of all sites. And last but not least, let's take a look at exotic species richness. Analysis of this dependent variable determined a significant relationship between presence of exotics and percentage cut. This was determined to be a positive relationship, meaning that the more that was harvested, the more exotic understory were able to invade. This was not surprising, as previous research has found similar results due to canopy cover openings following harvest. Some repeat offenders that we saw during field work include broadleaf helleborine, pictured left, forget-me-not, and English holly, 2 of which are classified as invasive by the California Invasive Plant Council. And moving on to our discussion, were our initial hypotheses supported? Well, as predicted, the late successional unit had the most late sterile features, including low stand density, the highest mean of large woody debris, highest mean of coast redwood-associated species, highest mean canopy cover, as well as lowest level of exotic species richness. And looking back at our explanatory variables, which one was the strongest predictor? Percentage cut per hectare. As we hypothesized, a number of features associated with late sterile forest declined in response to more intensive harvests. These included larger diameter coast redwood stems, large woody debris density, coast redwood-associated species, and canopy cover. Well, results for the other 2 explanatory variables, years since last harvest and number of harvest reentries, also yielded some important findings. Percentage cut was the most obvious predictor for change in several metrics relating to late sterile features. So, what does this information tell us? That a low cut is more important than anything else. This will lead to the greatest habitat features. Based on this study, negative impacts associated with percentage cut per hectare include an increase in stand density, especially for stems and smaller size classes, a decrease in large woody debris, a decrease in coast redwood understory associated species, as well as an increase in exotic species richness. And looking at the supporting research, the more intense the harvest regime, the longer the stands will take to regain floristic and structural complexity. Heavier logging regimes cause the loss of complex microhabitats, reduction of large woody debris, and alteration of temperature and moisture balances. And standard thinning practices increase stand density and result in an increase of stems in smaller size classes. So I think it's safe to say that we can refer to selective harvest as the golden child of harvest methods. And the important message to take away here is that volume matters, and a lower volume cut makes for a healthier forest. So our recommendations for forest managers include implementing lower harvest yields to promote higher stand heterogeneity and an even distribution of size classes, active management of exotic species, as well as an increase in time intervals between harvests, and studies have shown that short-term rotations cause a decrease in structural and floristic complexity. And that concludes my talk. Thank you.
Okay. We have time for one question here. Let me get you back here. There's lots of room up front, and if it makes it possible to slide between, then people can move a little bit closer. So here you go, Jason.
What impact did yarding method have on basically stems that were still on the ground, or did you consider yarding method involved? Because I noticed that
that it did have. No, that's a good question.
Large, or the late cereal one was cable yarded.
It was, yes.
Most of them seem to be tractor yarded.
Yes, the 1996 site was also partially cable yarded as well. And that was due to basically steep slopes. And so we didn't look at that in depth, but of course feel that yarding is probably the more ecologically sound way to go in terms of harvest. But with the comparisons between the 96 and the 2007 late successional unit, I mean, the 1996 harvest unit still had quite an abundance of stems. If we go back, this might take me a moment to go through all my, but just looking at this, and so you can see the 1996 site, despite the fact that they did do some cable yarding, there's just an abundance of smaller stems in the lower size classes. So definitely something that we would like to look at in more depth in future research. Yes.
When you use stand density, what are you referring to?
I'm sorry?
When you use stand density, as in this slide,
yes.
What are you referring to?
Stand density of coast redwood, we're looking at stems. So we looked at stems over 10 centimeters in diameter and basically did counts and then broke them up into size classes.
So it would be trees per acre?
Per hectare, yes. Stems per hectare, yes. Yes.
Okay, great.
Great.
Thank you.
Thank you very much.